Hello, children. I hope you're having a great day. I hope you're staying safe at home. So, to continue with the study of gas laws, today I'm going to teach you Boyle's law. Now, Robert Boyle studied the relation between pressure and volume of gases, and he found that at a constant temperature, the volume of a fixed mass of gas decreased by half when the pressure was doubled, and it became 4 times its original volume when its pressure was decreased to 1/4. So he described this behavior in the form of a law which is known as Boyle's law, which states that volume of a given mass of dry gas is inversely proportional to its pressure at constant temperature. That means if the pressure is increased, the volume decreases. If the pressure is decreased, the volume increases. Okay, so coming to mathematical expression of Boyle's law, supposing a gas occupies a volume V1 when its pressure is P1, we will see that V1 is inversely proportional to P1. Now, inversely proportional means when volume increases, pressure decreases. When pressure increases, volume decreases. So when we change the proportion sign to equal to sign, you know we have to multiply it by a constant k. Okay, so now cross multiplying, what do we get? We get P1 V1 is equal to a constant k. Similarly, if V2 is the volume occupied when the pressure is P2 at the same temperature is constant, remember, then what do we get? We get V2 is inversely proportional to P2, or again, when we change the proportion sign to equal to sign, it will be multiplied by a constant k by P2. Again, by cross multiplying, what do we get? P2 V2 is equal to constant k. That means P1 V1 is equal to constant k, and so is P2 V2 is also equal to constant k. Therefore, what do we get? We get P1 V1 is equal to P2 V2, which is equal to k. And remember, the temperature is constant. It does not change. So this is known as Boyle's law equation. So looking at the Boyle's law equation, we can also state Boyle's law as the product of volume and pressure of a given mass of dry gas at a constant temperature is constant. Okay, now moving on to graphical verification of Boyle's law. Okay, the first that we take is volume versus inverse pressure. Okay, so when we plot a graph taking volume and inverse pressure, what do we get? We get a straight line passing through the origin, because when the volume is 1, inverse pressure will also be 1. Okay, when the volume is 2, inverse pressure will also be 2, and so on. So in this case, you know that temperature is constant. It does not change. Now, next, when we plot volume versus pressure, okay, we get a hyperbolic curve. What is a hyperbolic curve? It is a curve like this, which is known as hyperbolic curve. Okay, now why are we getting a hyperbolic curve? Because we are plotting volume versus pressure. Okay, so you know when the pressure increases, the volume decreases. Similarly, when the pressure decreases, the volume increases. So what type of a curve are we getting? We are getting a hyperbolic curve. And here also, you must not forget the temperature remains constant. Okay, and now moving on to a graph where we plot P into V, pressure and volume when we multiply, versus pressure. Okay, so this side PV and this side pressure. So when we multiply pressure and volume, you know it is equal to constant. P1 V1 is equal to P2 V2 is always a constant, does not change. So how much ever pressure you give, PV value will remain the same. So what type of a curve will you get? You will get a straight line which is parallel to the pressure axis. Okay. Now moving on to the explanation of Boyle's law in terms of the molecular motion, that is the kinetic theory. Now according to the kinetic theory of gases, the number of molecules that is present in a given mass and the average kinetic energy which these molecules possess, it is always constant. So if the volume of a given mass of dry gas, supposing we take some dry gas in this container and we reduce it to half the volume, what will happen? It will now have half the space to move, isn't it? So as a result, what happens? The number of molecules, all these gas will be reduced to this half space. So the number of molecules striking at unit area of the walls of the container will be doubled, isn't it? Because now there are double the number of molecules in half the space. So the pressure also gets doubled. Conversely, if the volume of a given mass of gas is doubled, now supposing we double it, double the volume, what will happen? The molecules will all spread in the entire space available to them at constant temperature, and the same number of molecules will have double the space. Now it has double the space to move about. So the number of molecules striking at unit area of the walls of the container at a given time will become half its original value. Thus, the pressure of the gas will be reduced to half its original pressure. So we can see that if pressure is increased, the volume decreases. So in this case, the pressure had been increased, so the volume has decreased. Okay, so that proves Boyle's law. Now next we come to the significance of Boyle's law. Now when pressure is increased, volume decreases. That means the molecules come close together. It becomes denser. Thus, at a constant temperature, the density of the gas is directly proportional to its pressure. That means if the pressure is increased, the density also increases. So we know that atmospheric pressure is low at high altitudes. That means if you compare the pressure in the hills with the plains, you will see that atmospheric pressure is low because the air is less dense. Now, maximum of the air will be concentrated in the plains. So, as a result, there is less quantity of oxygen. So, that is the reason why mountaineers have to carry oxygen cylinders with them when they climb mountains. Why? Because as they go higher and higher up, as they gain higher altitudes, there is less oxygen for breathing. Okay, so when air is blown into a balloon, supposing you take a balloon and you blow air inside the balloon, you will see that the volume and pressure inside the balloon increases. Volume also increases, pressure also increases, isn't it? Why? Because you know, I think you've seen, no, sometimes if you put in more air, the balloon will burst because due to the increase in pressure. But Boyle's law is not violated as the law is valid for a definite mass, whereas mass increases when more air is blown into the balloon, because as you put in more air, as you blow in, you are putting in more and more air. But when we talk about Boyle's law, we are talking about a fixed mass of air. That means the mass is not increasing. Okay, so this is all for today. We've completed Boyle's law. Please go through the chapter as well, and please let me know in WhatsApp if you have difficulty anywhere. So have a great day, children. Stay safe. God bless you.